In this lesson, we are going to be writing a recursive rule for the geometric sequence, remembering also how to write an explicit rule for the geometric sequence, and then be able to write one from the other. Let's review. The geometric sequence is a sequence where each term changes at a constant rate. So we talk about our examples where we're going from 5 to 10, 10 to 20, 20 to 40, and so on, where we're multiplying by 2 to get to our next term. Or where we are going from 12 to -6 to 3 and so on, and instead of saying we're dividing, we actually do want to show that we're multiplying. So to get that to be smaller, instead of dividing, we are multiplying by a fraction, which in this case would be 1/3. But to change the sign each time, it's going to be a -1/3. And then we looked at some non-examples. The explicit rule was the formula equation that allowed us to calculate any term in the sequence. So for the geometric, I have any term I want, which is a sub n. I simply take my first term, a sub 1, I multiply it by the rate to the power of n minus 1, where n represents the term of the sequence that we are looking for. So, if I want to do the recursive form, a to the 1 means I need to list my first term, and then I simply need to do the formula a sub n. A sub n is the term I'm looking for, equals the previous term, a sub n minus 1 times r, which is the rate. So let's do an example. Here's what we do. We take our a sub 1. In this case, our a sub 1 is 2. Then I need to write the rest of the rule. So I have a sub n, the term I'm looking for, is the previous term, a sub n minus 1, times the rate. What we need to do to find the rate is decide how are we getting from one term to the next. And it looks like I am multiplying by 4. That is my rate. I can also write this by putting the 4 in the rate in the front and then doing a sub n minus 1. Let's take a look at the next example. In the next example, I see that my a sub 1, or my first term, is 9. Then I need to find my rate. How am I getting from 9 down to 3? From 3 down to 1? Well, I'm dividing by 3, but again we're going to use our constant multiple. So instead of dividing by 3, I'm going to be multiplying by 1/3. So to finish my recursive form, I'm going to take a sub n, and I'm going to multiply my previous term by 1/3. So I have 1/3 times a to the n minus 1. So let's write the first 4 terms of our sequence. So to do that, when we are going to look for the first 4 terms, I know that my first term is 3. To find the next terms, I'm simply going to multiply by my rate, and that's going to give me my next terms in my sequence. So 3 times 2, my next term in my sequence would be 6. 6 times 2, the next term in my sequence would be 12. 12 times 2, the next term in my sequence would be 24. My first term in this sequence is -3. That is my first term. Here is my rate, and it tells me to get all the rest of the terms in my sequence, I simply need to multiply by 3. So -3 times 3 would be -9. -9 times 3 would be -27, and -27 times 3 would be -81. That's how I get the first 4 terms in my sequence. Now I would like to take one of the rules and be able to write the other rule. So if I am given the recursive rule, which in this example is written here, I want to be able to write the explicit rule. So I'm given my a to the first, which is 13, and I'm given my rate, which is 4. So to write the explicit rule, I have a to the n power, or the term I'm looking for, is my first term, 13, times my rate, which is 4, to the n minus 1 power. Here is the recursive rule for this example. I want to write the explicit rule. All I need to do is find out that my a sub n, the term I'm looking for, is equal to my first term, which is negative 9. I'm putting it in parentheses to make sure that I am holding the negative sign next to it. I'm going to multiply that by the rate, which is 7, to the n minus 1 power. In the next example, I am given the explicit rule, and I want to write the recursive rule. The recursive rule, I must find my a2, a sub 1, which is my first term. In this case, my first term is 3. Then I need my rate. My rate is 6. So to write the rule, I have a sub n is equal to my rate times my previous term. My rate is 6, and I'm going to multiply that times my previous term, and we can write it in that order. You could also write it in the reverse order, putting the 6 in parentheses after. Here is my next example. This is my rate because it is to the power. My first term would be located right here. And I don't see a first term, but remember, we always understand that the number 1 is written in front of the 9, or in front of whatever variable I'm talking about. So I want to write my explicit rule. So I have, now writing the recursive rule, a to the 1 is equal to 1, and then I have a sub n is equal to my rate, which is 9, times a to the n minus 1, or a to the n minus 1. So now, if I give the information, I want you to be able to write both rules. So for the explicit rule, remember that the explicit rule is a to the n, and that equals a sub 1, or our first term, times our rate to the n minus 1 power. So for that rule, I have my a sub n, and that equals my first term, which is 11, times my rate, which is 6, to the n minus 1 power. To get the recursive rule, we have to start with our a sub 1, and then we have a sub n is equal to a sub n minus 1, or our previous term, times the rate. So my a sub 1, to get my recursive rule, in this example, my a sub 1 is equal to 11, and then my rule would be a sub n is equal to my previous term times the rate. My rate is 6, and my previous term would be a sub n minus 1. In this example, to write the explicit rule, I have a sub n, and that equals my first term, which is 5, times my rate, which is 1/4, to the n minus 1 power. My recursive rule, I need to know my first term, a sub 1, is equal to 5, and the rest of my rule would be a sub n is equal to my rate, which is 1/4, times a sub n minus 1, or the previous term. Let's review. Remember, a geometric sequence has a constant multiple or rate. The explicit form, when we're looking for any term we want in the sequence, is a sub n, that term, equals the first term times the rate to the n minus 1 power. The recursive form is we first look for a sub 1, our first term, and then to finish the form, we have a sub n, any term we want, is equal to the previous term times the rate. Please remember to do the reflection.